up close and personal feature at OHBM. So the program committee came up with this idea to try to kind of give the membership, a feel for the sort of a more personal feel for the lives of some of the most extraordinary members of the organization. And it seemed like the perfect inaugural guest for the feature was the this year's Glass Brain Award winner, Susan Bookheimer. So, you all heard a lot about her last night at the ceremony, but I'll just say a couple things. She holds the Joaquin Fuster Chair in Cognitive Neuroscience and is director of the Staglin Center for Cognitive Neuroscience at UCLA. She's been long active in the OHBM. As you heard, she served as chair in 2012, meetings liaison back in 2003 for the Budapest meeting. That was actually the first time that I was involved in the organization as well. She was the head of the local organizing committee for the 2009 meeting. So on a personal note, when I moved to UCLA in 2002, Susan was super generous and helpful in kind of, getting me integrated in the community there and also pulling me into OHBM. So let's welcome Susan.
Great. Thanks, Russ. That was really sweet.
Sure. So I should say, we're going to take, I have questions to ask Susan, but we'll also at some point, I'll pull out my device and look at the questions online. And so if you have particular questions that you want me to ask her, go ahead and post them. You can get to the site via the app. Go to the whatever it's called, audience response button, and then go to this particular talk, and you can enter your questions there. So why don't we just start by having you tell us a bit about how you got started as a neuroimaging researcher?
Sure. So I'm trained as a neuropsychologist, and my specialty was in epilepsy and in brain mapping in the old-fashioned way, which was with the WADA tests and with electrocorticography, so direct stimulation for patients who had epilepsy and were going to have surgery to remove the epileptic focus. So hence my interest in language and memory, because that's what we worry about during epilepsy surgery. So I happened to be at the NIH back in the beginning of time.
I wasn't going to ask specific dates.
Thank you so much for that. A long time ago, let's say, when there were still dinosaurs roaming the earth. I was at the NIH, and I happened to be there when they had this cool new device called a PET scanner. And before that, they'd had PET, but it was mostly used with the FDG, and they had just developed water PET. So that was the first opportunity to really do activation imaging, because it had a relatively short half-life compared to FDG. And so in about a 3-hour period, we could do approximately 6 injections, so 3 controls and 3 activation tasks. Back then, what we would literally do to do language mapping was to do a craniotomy, open up the skull of one hemisphere of the brain, sometimes both hemispheres of the brain if we didn't know where language was coming from, do direct stimulation over a period of days to weeks while we're recording seizures, and try to find out where the language areas were. And at the end of all that, of course, that's a diagnostic procedure, right? So you could get to the end of all of that surgery and then not be able to do anything for the patient. So we had the idea, after Steve Peterson published his first language paper, that we could perhaps try to do this language mapping in patients with epilepsy. We figured it'd be really easy because everybody knows there are 2 language areas, Broca's area and Wernicke's area, and all we needed to do was to do a simple language task, because all language tasks had these things in common. And so that's what we did. And of course, we immediately found that the language system was not anywhere remotely similar to what we were told in graduate school and in medical school, and that it was much more complicated. And so that started a career in just learning to do neuroimaging. And then, again, lucky me, I happened to be there when fMRI was invented, and we had the opportunity to do fMRI at the NIH with some really great people at the time. Peter Gizzard was there, Denis Lebien was there, Bob Turner was there, and the guys from MGH who had had developed it, particularly Jack Beliveau and his crew came down to the NIH, and we all started doing mapping together. So and that was it. Then that was the rest of my career.
Cool. So can you say a bit more about sort of what the transition was like going from PET to MR? It'd also be interesting to hear, given what an interesting character I think Jack Beliveau was, like, the experiences that you had with him. So many of you may have not heard of Jack Beliveau, but he was really kind of, one of the discoverers of fMRI. And he passed away a couple of years ago, but really had a lot of influence on the field.
Yeah, Jack was brilliant, and he was a lot of fun, and I guess people who know him also know that he died of end-stage liver disease because he drank, and he did drink horribly back then as well, but he was a really interesting guy. He always wanted to try new things. He thought out of the box. And I'll just tell one story, and that was that every OHBM that we went to, and before OHBM it was cerebral blood flow and metabolism, because we didn't have an HBM back there, and so we were doing PET scans, and the early fMRI studies were also presented at cerebral blood flow and metabolism, just because there was no other place to go. And we would always go to the bar, drink, and charge it to Jack's room. So everyone did. He would have these $3,000 bar tab bills, and that Bruce Rosen would always pay. Probably it was bad because we enabled him. It was such a fun and exciting time. We didn't pay for scan time back then. The scanners were just basically hand built practically. We were kludging it just to try to get these scanners to do functional MRI before EPI was built into any of the systems. We had to cheat the scanners basically into doing functional imaging. So we would scan one slice at a time, literally using an SPGR sequence. So we had 8-second TRs. We would do one slice at a time. And what we'd have to do is fool the scanner into doing imaging in doing a time series. So we would have to press the slice selection button like 65 times in order to get 65 data points. We'd be sitting there like this, pressing again and again and again. And there was no there was no equipment for doing activation studies inside the scanner. All we had was the intercom system. So we would start these scans. It was very, very loud. We didn't have any good ear protection back then, and we would press the intercom button and scream as loud as we could. Think of words that begin with the letter H. Stop and rest now. And that was language. That was language.
And you couldn't just go download SPM or FSL, one, because the internet didn't exist, but also because those software packages weren't really around yet, right?
Yeah, so there was no software at all, and particularly in the early days of PET, even before fMRI, we didn't know where the functional activation areas were going to be. So we had what was then like the most sophisticated software program around, which was a surface-based registration that was written by a guy named Chuck Pellizzari. So we would get an MRI scan of the whole brain, a volume study. You'd have to do 3 of them. You have to do one in axial, sagittal, and coronal because they didn't have any 3D representations back then. And we would draw a surface around every single slice of the brain. So that was 124 slices times 3. And we did the same thing with our probably 10 PET slices. That's all you got back then. The resolution was terrible. And then we had the surface registration program that would see these points on these lines that we drew painstakingly, which would take hours and hours, and it would try to match up these 2 surfaces. It would just move them around until they kind of matched up. And then to extract data, what we'd have to do is draw regions of interest on the MRI scans. And of course, what were the regions of interest? We didn't know, so we just drew every sulci and every gyrus in the brain. So we would just draw all of area 44, all of area 45. We learned neuroanatomy really.
This is why you know anatomy so well.
Yeah. So to this day, you can name 3 coordinates in Talarex space, and I will tell you exactly where it is. Or you can name a structure, and I will tell you what the 3D coordinates are. You never forget that kind of stuff. But the ironic thing at the end of that was that we would draw all these gyri, get the PET values extracted from this whole gyrus, and And in the end, what we learned in PET was that all the activation was in the sulcus, and so we would cut all of our activations in half. It was a useless task at the end.
And in designing the studies, did you go into fMRI kind of just doing the same thing you had been doing in PET?
Yeah, initially we did. I mean, we didn't know what good experimental design was. The very first experimental designs were these super hierarchical designs, which we ended up rejecting very quickly. But we did the simplest tasks we could. The main reason was that we didn't know that the systems were more complex than that. We figured, okay, we will just show people objects. That's what we did with electrocorticography. Show people an object, have them name the object, show people words, have them read the words, and then we'd have a control condition, which was usually rest, or else look at a crosshair, and that would be the end of it. And then it got more sophisticated. We would have people look at words but not say them out loud, and then look at words and read them out loud. And presumably, you did the same thing with objects. You get this final common pathway of motor output. All of those things turned out to be wrong.
So you're one of the few people who's really successfully bridged kind of the basic and clinical worlds. Do you want to say a bit about how you feel about that relationship and sort of where you see that going?
Well, so, I personally feel strongly about it, but that's because I am a clinician, and the patients that I work with are very sick patients. I don't see patients very much anymore for other reasons, but the patients that I do work with have brain tumors. They're going to die. And I do some work with Dr. DiPreto in autism as well. So we see patients who are very sick, and my goal had always been to be a clinician and to help people who were ill. I went more into the basic areas because it became clear that if I didn't, we wouldn't know what we were doing. It became clear that we didn't know what we were doing, and that that the models of the brain that had been developed from lesion studies were so incredibly crude that I just couldn't do my work without becoming much more of a basic scientist. And of course, that was a lot of fun too, and it still is a lot of fun.
Yeah, I mean, this is like one of the challenges is, right, that you have all these constraints in doing clinical stuff that you don't have when you're doing basic research, either on availability of patients or what you can do with them. So after you started doing basic work, did you get more frustrated on the clinical side, or?
Not really. I always enjoyed working with patients anyway, and particularly with patients who were going in for brain surgery. It's really was the most rewarding work I did. And we still do electrocorticography, and we still do WADA tests, just not nearly as often and much more efficiently now that we have functional imaging. So no, it's certainly more challenging to get a patient in the scanner, particularly a very sick patient in the scanner. The people who work with kids, I think, have it worse. Kids with severe disabilities are a really hard group to study. But no, that's been fine, and that didn't bother me. I think that it's less interesting than doing the basic science and coming up with interesting ideas for experimental designs and really trying to think through what's the best way to answer this kind of a question, and then how to translate it. Even more difficult because you have problems such as difficulty level, which can screw up all of your results, but are absolutely essential to understanding when you're working with patients.
So, how do you feel about how the organization is kind of spanning that gap in the role of clinical work in OHBM?
It's interesting because I being on the council and the program committee for many years. The biggest one of the biggest categories of submissions we get is the clinical category, right? So we get two major categories: methods and analysis, and then clinical. And there often isn't a lot of crosstalk between the two, which I actually think is a shame. It seems like they're the clinical people, and then they're the methods people, and they don't interact as much as I think they should. I personally believe that that imaging, functional imaging in particular, but also structural imaging and the kind of work that we do here at Brain Mapping is going to profoundly change clinical science. And in particular, things like clinical trials, clinical trials for drugs or for any kind of treatment. But let me use, for example, Alzheimer's as an example. Our very best clinical trials now they do in patients who have MCI, mild cognitive impairment, which is a nice way of saying you're going to get Alzheimer's in a few years. And so what do? You recruit these very sick patients, and you give them a drug, and then you wait for them to develop Alzheimer's disease to see if your drug is working. And like that's a really awful thing to do. You know, like half of your subjects are getting a placebo, and you know they're all going to get Alzheimer's disease. And so I think that using imaging as our best biomarker, you know, looking at measures of early preclinical disease, and even just early changes in or even fundamental differences in organization that are predictive of a disease that might occur years later, is really the best way to do clinical trials. And I think that drug companies are just starting to realize that that might be the case, and ultimately, I think the trials will be much, much more successful because you're looking at an actual biological variable, not this long-term behavioral outcome, which is going to be influenced by many other factors other than the biology of the disease. And we don't have to wait till the person gets the disease and is about to die before we find out the results of our clinical trial. So I really think that that imaging is going to play a major role in the future of clinical science, and it behooves us as clinical scientists to use the best methods of acquisition and analysis as we're doing that. And I think that's a bridge that needs to be built better as well.
So let's move to more sort of personal stuff. So the Me Too movement has brought increased attention to how women are treated in society and in science. And OHBM has had its struggles with gender equality in the last few years. So as someone who came of age in an era when bad behavior by men in power was kind of taken for granted, how do you view sort of how these changes have happened and where things are going?
Yeah, so when I was in training, it was perfectly common for example, bosses to make passes at their employees, to advisors to make passes at their students. My internship advisor, I was pregnant during my internship. My internship advisor was felt very comfortable telling me how much he disapproved of women having babies and careers at the same time. And I'm going to work with this guy every day, and he's telling me how much he disapproves of this. That was common. I was at Yale back then, and I was in the neurosurgery division, and there were 50 men and me, and I was pregnant. They thought I was from Mars. I mean, it was really, it was crazy. People said the cruelest things, and they thought nothing of it. So I think that kind of very explicit stuff has diminished somewhat over the years, and I think it's tremendous that it has. And I'm very happy to see the Me Too movement, that people are talking about it. It seems like for that to have been successful, you had to have a critical mass of women who were ready to talk. And I think that's great, but it also means, in a particular person's case, that the perpetrator has to be extremely egregious, a serial abuser, in order for enough women to say, no, this particular guy has done some bad things, for people to finally prick up their ears. And I'm sure this is true of all the women here, but I don't believe there's one of us who has not been harassed in some way. I mean, I have. I've been pounced upon, literally pounced upon several times. And that's just the most egregious of it. So, I mean, I think it's great that people are calling it out. But I think that the problem is so much deeper and so much more subtle than that. Being explicitly sexually harassed is at least illegal now. Didn't used to be. So that's fantastic. But the more subtle things are the implicit biases, for example, that I think are a huge problem in grant reviews and paper reviews, in tenure decisions, in hiring decisions. And a lot of people don't realize that it's going on. Women don't realize it's going on. I think one of the best examples of that I run into in my own work, it has been the case with me as well as with women I work with, is, a couple of them. One is the assumption that if you're married to someone who's also a scientist, you must therefore, if you are female, be the trailing spouse. When I came to UCLA, that was the assumption, even though, in fact, the first contacts I made at UCLA were with me, not with my then husband. But people just assumed that. So I think that's something that we all have to deal with. The other one is that the assumption that women are not technically minded or mathematically minded. So, for example, early on when we did some work in unfolding the hippocampus, that was one of the things I did a number of years ago. We mathematically unfolded the hippocampus to look at subregional activity. And on I think the third or fourth paper that we published on that, Paul Thompson was a collaborator with us. He'd done some group mapping with us as well. And from henceforth, everyone assumed that Paul was the person behind all of the math that we did there, even though we'd published the papers years before, when he was still in graduate school. But there's, again, this assumption. And I see this a lot, particularly in the women I know who are very mathematically inclined, that there is just an assumption that they can't have done that themselves, that they must just be the end users. And this is an implicit bias that I think follows us all today.
So what do you think the things are that the people in this room can do to help make that better?
Yeah, so I want to have a new movement, and this is called the Call Them Out movement. This is trying to make the implicit explicit, and not being shy about naming names, even if you're the only woman who's being affected. And I would like to think that men can play a much firmer role in calling it out when they see it. I know, for example, in the recent Dartmouth scandal that many of you have read about, that I know many men who've known about this for years. They've known about these guys' behaviors. So you guys should be calling it out too, and not just relying on the women who are the ones who are going to get hurt if they call it out and other people don't believe them. But the men who are observing this can call it out just as well, and I think that would be helpful. So I think that learning how to deal with implicit bias is it's very, very difficult, because by its very nature, it's implicit. We don't really know that we have these biases. So it's important to have metrics, facts that we can look at to say, hey, our behavior is biased, even if we don't believe it, even if we are not aware of it, and to try to, as best we can, to be enough aware of implicit biases to make the assumption that we probably have it, I have them as well, and to call them out and to make the implicit explicit and make that part of all of the things that we do in formal occasions like hiring decisions and tenure decisions and so forth, just to go through the formal exercise of saying, okay, these are the implicit biases that are common. Let's make sure we're not doing them here. Let's think about that. And just bringing it always to the forefront, to the extent to which we are always talking about this, and not just the women, but men are talking about it. I think it makes it less likely that this can be perpetuated, and more likely that we can start making progress.
Yeah. So what do you think have been the most important keys to your success?
So the first one would be luck, being in the right place at the right time. I was very fortunate to be at the NIH when great things were happening. I just happened to be there, and I was lucky. I think jumping on opportunities when they present themselves is something that it helped me a lot in my career. I wish I could say that it was like my great perception of the future or anything like that got me into this field, but that's really would be completely untrue. I just followed where the things took me. If there were one thing that I could say that I did actively that contributed to doing well in my career, that is being collaborative, forming collaborations, being as helpful and generous as I possibly could be to other people, younger scientists, but anybody really who asked. That it was personally rewarding to me, and you never know where your career is going to go. I mean, I didn't know that I would be doing any aging research, for example. I sure didn't know I was going to be doing any autism research. It just landed on my lap, unwillingly, I will say. But you just grasp at the opportunities that are placed in front of you, and in both the aging world and in the autism world, I got involved because somebody asked me to, and I was trying to be helpful and generous, and that turned out to be great for my career. So I think that just being helpful and generous has been what I've done that I've enjoyed the most, and that has been the most helpful.
Yeah, well, you were certainly very helpful for me when I was young. So, so what advice would you give trainees about, what should they do to be successful?
Yeah, so I'm asked that a lot in a variety of different ways. I think one of the questions I get asked a lot is by young women, when do I have a family? When's the best time to have a family? And I tell them when you're fertile and you feel like having a family, don't wait. That's the time to do it. In the grand scheme of things, it doesn't actually make a big difference that you took off time. I took off 3 years for my first child. I took off 3 years from work for my first child. A lot of people don't know that. And think it turned out okay for me in the end. So I think it's really important to keep that balance. The other thing that I tell trainees a lot is we don't know what roads we're going to go down in the future. It's impossible to predict the future. We don't know what opportunities will become available. So one of the things I always advise people is to look at the opportunities that are in front of you right now and jump upon them. And that's what's very important. I had one student a while back who was offered a great job at a great university, but not one where she really wanted to be long term. She said, I really want to live in the Bay Area. Like everyone wants to live in the Bay Area. I'm sorry. And so she was going to turn down this job opportunity. I said, you can't do that. You don't know when an opportunity is going to come up like this again, or if there's going to be one in the Bay Area. And this is a great opportunity. Jump at it. Nothing you do is carved in stone. You can always move later. We can change our career trajectories. The decisions we make now are not nearly as weighty as I think sometimes we feel they are. So jump on it and go for it. And she did, and she's actually done marvelously. And of course now, she thinks it's the best university ever, and she met her husband, and so.
Cool. So I'm looking at some of the questions that have been posted, and so some of them we've kind of already touched on. The top rated one is, what advice would you give a young female researcher getting into science? But I think we've, I don't know if you have anything to add on that, but I think we've hit that.
Well, like, the family stuff, I say you just go for it and don't make that a part of your decision-making process. I do have another piece of advice that I give young women that I think that is very difficult for them. I'm very outspoken, you might have noticed. I think that the reason for that is because I didn't have a mother growing up. I only had male role models, and males anyway. I won't necessarily want to call them role models, but so I never was taught that girls should be quiet or unassuming or not speak their minds. I was brought by people who were loud and arrogant and said whatever the hell they wanted. So that has also served me well. It's also served me poorly at times, but for most of the time it has served me well. And
it made you feel very at home in a neurosurgery department, right?
Exactly. Yeah, that's a tough crowd. And as a neuropsychologist, by the way, in a neurosurgery team, which the epilepsy and surgery teams they're teams of individuals, and you're fighting with a neurosurgeon. And the neurosurgeon I worked at for the longest is Itzhak Fried. If anybody knows him, he's very outspoken, and so you have to be equally outspoken to get your point across and to protect your patients, because he would have been tearing on hippocampi all over the place if I didn't tell him you can't do that. So one of the advice I have for women is to leave behind those rules that you were taught about girls being nice and being unassuming and not arguing, and learn how to be outspoken. It's just extremely important.
So what have been, in your opinion, the most fortunate and unfortunate changes in the field over the years?
In the field of neuroimaging?
Yeah.
I'm trying to think if I can think of anything unfortunate, because I think that we learn from all the things that happen, even if they don't turn out as well. There was a brief period of time where I heard a few people saying that they thought that we should give up activation imaging and only do resting state fMRI. And there was a period a couple of years ago at OHBM that the resting state studies so far outnumbered the activation studies that I was afraid that we were going to lose activation imaging. I think that is a huge mistake. And I certainly do resting state imaging. I think it's important, but I really don't think that a very limited number of resting state networks are going to tell us a lot about cognitive function. So I think that trend was a mistake, and I do believe that it's starting to turn around again. And I hope that we will again start to see the kinds of very interesting cognitive neuroscience designs, experimental designs that are so cool and so fun to do and so interesting and also informative. I hope that we see that trend continuing.
So what do you think of the ongoing reproducibility problem and sort of the role of OHBM in that?
So I have a very different take on the reproducibility problem than you do, by the way. So let's have this discussion. So I think that there are very few true replications in science. Most people don't try to replicate a study. They try to replicate and extend, or they try to almost replicate but change a parameter that they think is going to be important. And in doing so, they don't replicate. But that failure to replicate is an informed failure to replicate. They don't replicate because they say, I think that this other variable is the reason why your study came out this way, and really if you changed it, it would come out this other way. And the failure to replicate is actually informative. It's extremely informative, and that's how we move science forward. And I think science has always been designed that way, where you come up with an idea, you do an experiment, and then everybody else tries to tell you that your experiment is completely wrong by changing a few parameters and saying, aha, you said it was for this reason, but it's really something else. And all of these things advanced science. That's what science is all about. So I don't have the same concern with the replicability problem, because I feel like every time we make one of these changes and come up with a different answer, that drives us forward. And that the good ideas and the ideas that are really true will withstand this barrage of insults and this barrage of additional experiments, and ultimately that's how we get to truth. I do think it's helpful to have larger N's, and I think we are getting larger N's as we go forward. And I also don't feel the same way as others do about, you state your hypotheses in advance and you only really report on the data that you've hypothesized, and then all these other findings that you get, you have to ignore them because you didn't hypothesize that. And I just completely disagree with that approach. I think that, and I tell my students this, the data are speaking to you. They're telling you what the truth is. So my idea about what the data should be doing is not necessarily the right idea, and a lot of people spend a lot of energy trying to force the data to do what their preconceived notions are, when I think the data are telling you the answer. And yes, that's exploratory, but that's okay. You say it's exploratory. This is what we found. It suggests this. Is this true? I don't know. We have to go out and study that some more, but I think that's okay, and I think that's how science needs to be done.
I don't really disagree with that.
Okay, good. Because I know a lot of people feel very strongly about, you have to have huge N's. Everybody has to have the same result. And, that also makes the assumption that people are homogeneous, and they're not. And I think that exploring heterogeneity just generally is important, and that's a new direction I think that people are increasingly starting to go down, and I think that's also very important.
Yeah, I agree with that. So another of the questions was about sort of time management and work-life balance, and how you kind of straddle those issues.
Balance. Could you spell balance? Yeah. So that's really difficult. I have found only in the last few years have I tried to tackle the balance issue. I think someone said recently, nobody ever gets to the end of life wishing that they'd worked harder and spent less time with their children, and I think that that's really true. And I worked way harder than I should have and spent less time with my children than I should have. It's worked out okay. They're not too crazy. But, the only thing I can say is that I set a few rules for myself, and that is, for the most part, I don't work at home. I try to not work when I get home. There's exceptions to that, but I do that. And other than that, I can tell you that I have not lived a well-balanced life. But I'm trying to change that now that I'm older and traveling more for fun and spending more time with the family.
So I'm going to ask you one that I swear is actually on here. Favorite swear word?
Okay, somebody knows me who asked
I know.
that question. Okay, all right. So now I will tell you that I had a completely non-swearing household. I would not let my kids swear at home. I wouldn't let guests visiting swear at home. I was like this total radical non-swearer. And then I got in a car accident 4 years ago, and I got frontal lobe injuries, and I got very disinhibited. And immediately, like at the scene of the accident, I'm throwing out the F-bomb like it was nothing. And now my kids all swear all the time at the house, and I tell them, no, you're not allowed to swear at home. And they say, what do you mean? Look at you, what you're doing. So my favorite swear word is obviously the F word, because I can't help myself from saying the F word. And it's not even that it's favorite. It just comes out all the time, and I'm trying really hard not to swear while I'm up here.
You've done a good job.
So far, I'm getting better and better, and I hope that I will be able to leave here without using the F word.
Right.
But we'll see.
So I don't know. There's one more question that I want to ask to finish off, but before I do that, does anybody have questions that you'd like to ask that you haven't put into the attendee response system? Okay, so we will finish off with this one. If heaven exists, what would you like to hear God say when you arrive at the pearly gates?
Gosh, that's really hard since I don't believe in God or heaven. What would I like God to say? Yo. Way to go, bitch.
On that note, thanks, Susan.